Okay, I'm going to do the falling body problem one more time, and then the jumping of the trampoline one more time, just because we ran into some glitches today. Because I don't know what I think my cold medicine was affecting me too much or something. But let's just take a ball. Let's just take a simple ball being dropped. Okay, I've already done this video once, and I went 9.8 times 10 is equal to 980. So instead of 98. I you know, it's been that kind of day. It's got an initial velocity of equal to 0 in the y direction. Initial height, 10 meters. Okay? Final height, 0 meters. And we're going to show how this force times distance, this work done by gravity is positive here. And it will give, and it's a positive work is being done, so therefore we have a positive change in kinetic energy. If we do negative work, it slows it down. Okay, and that's with the trampoline. If we do positive work, it speeds it up. If we do negative work, we work against it. If we're slowing it down, if we do negative work, then it's going to slow down. The kinetic energy is going to go lower. That's all there is to it. That's it. Okay, positive work speeds up. So the key, positive work speeds up. Negative work slows down. Easy as that. I've never taught it that. But that's the way most human beings would look at it. Besides physics people, because we get wrapped around the mathematics too much. But that explains what's going on here. So it's going to speed up as it's falling down, and if we throw it up in the air, it's going to slow down until it comes to rest. Okay, so let's look at the work done by gravity. Work done by gravity will be equal to the force done by gravity times the displacement times the change in h, which is the same thing as d. Change in h is equal to d, okay? And the angle is 0, so therefore the cosine of 1, which is equal to, that should equal, my change in kinetic energy. Well, let's look at the work done by gravity. It'll be m times negative 9.8. Now the change in h. The change in h is equal to h final minus h initial. That gives me negative 10. Because here's the force, negative 9.8 times negative 10 is equal to my change in kinetic energy. And look what I get. I get m times 98 is equal to 1/2 mv final squared plus 1/2 mv naught squared. That's 0. And so let's cancel m's. Cancel the masses. And I get 2 times 98 square root is equal to v final, which equals 14 meters per second positive. But notice I get a positive number over here because it's negative times negative. So gravity's doing positive work. Now, the guy on the trampoline, so the trampoline guy, okay, he's going to take off and he's going to do negative work. His work is going to be negative, so therefore, ergo, he's going to be slowing down from his initial velocity because we know his final velocity is going to be 0. All right, so I think he took off from a height. I can't remember. It doesn't matter. It doesn't matter. So let's just take any trampoline guy who catapults up. All right, so he leaves the trampoline at an initial velocity that we don't know, reaches a final velocity that equals 0, and we know the distance that he traveled, okay? Now, the work being done by gravity is going to be 0 because it's going to be negative because it's going to take him down, all right? Let's say, I think he went he went from 1.2 to 3.6, right? Or to 4.8. So if his initial height was 1.2 and his final height is 4.8. Let's just do the displacement again. Okay, let's just do it again. So we've got mass. So the work is equal to the mass times negative 9.8 times 4.8 minus 3.2, which is positive 3.6. That's negative work. That's equal to negative. Is equal to 1/2 mv final squared minus 1/2 mv naught squared. Well, looky there. So we've got m times negative 3528 is equal to 0 minus 1/2 v naught squared. So I think I got lucky today, and we just kind of m v naught squared. So let's cancel the m's. Get negative 35.28 is equal to negative 1/2 v squared. Multiply by 2. Multiply by negative 2 from both sides. Might be going, okay, so why is he multiplying by negative 2? Because it makes it positive. Because you're going to divide the negatives and make it positive. .4. V initial was equal to 8.4 meters per second. There you go. That shows you how the work energy, instead of using energy before equals energy after, which we're not quite ready for. We didn't get to conservation of energy yet. But you can see how the work, negative work is done here because look, the work is negative. It slows him down. Positive work is done here, which speeds him up. All right. I feel much better. If you watch this or not, I don't care. I feel better.